In this video, I want to talk about basic measurements and how to program them. So in the previous video, we went through the alignment. So we already have some features. We've got two 2D lines and a plane. We're going to have to add a few more features to get all of the characteristics we want. So a feature is just a physical portion of the part that you're going to measure. The characteristic is what's on the drawing. So you could find a circle on the part, but the characteristic would be the diameter. Now there's different ways to get the characteristics. Sometimes we can report them from the feature, so we don't have to do a bunch of extra clicking. I'll show you both ways to do it. But the first thing we need to do is look at the drawing and figure out what kind of information we want. So on the drawing, and I'll put it on the screen, we've got the width of the part at 3 inches plus or minus 20 thousandths. We're going to want that. We're going to want the height of the part, again 3 inches plus or minus 20 thousandths. We're going to want that flatness, that geometric tolerance, and then we're going to want the diameter and the X and Y coordinates for all 16 of those holes. Now I'm not going to go through all 16. I'll show you how to do about 4 holes and you can follow it from there. It gets pretty repetitive. So the first thing we'll want to do is open our program that has the basic alignment. We'll go through and check and make sure basic alignment's still good, make sure our clearance planes still look good, okay? The cool thing about Calypso is that any features you use in your alignment will also get used in your characteristics and features when you're running the program. So it's not going to say our alignment checks this top plane, it's going to use that for the flatness, okay? So it's not going to run it twice. So anything you use in alignment can be reused. So you typically want to use the same features for alignment as you do for checking the actual part in the program. So I'm going to go to the computer screen here. I see that I've got my 2D line 1, 2D line 2, and plane 1. I'm going to want to add a 2D line on this side of the part and add a 2D line on this side of the part. That way we can get our distance, right? So as always, I'm going to drive the machine over there. I'm going to shoot for about halfway down the part, take a point, move straight out, drive over here without moving the probe up or down. That's important. Drive straight in, take another point. Now, on the computer screen, I can see my features. It identifies it as 2D line 3. It's got a bunch of numbers we don't really need. And I'm gonna hit OK. You gotta hit OK before you go probe something else, or else the computer will get confused and it'll think you're trying to make another different kind of feature, right? So we only needed those 2 points for the 2D line. Now, I'll drive the machine. I want to make sure I clear my clamp, right? Get up and over it. I'm gonna go to the top of the part over here, take 2 more points, right? And it's good practice to move the probe above the part in between checking stuff. That way, if you bump a joystick or something, it's not gonna smash into something, right? So we've got, again, to the computer screen, 2D line 4. I'm gonna hit OK. It's good practice to name your features. In this case, I won't because I didn't do it in the previous video, but you can name these, for instance, top plane, left side of the part, top of the part, bottom of that kind. That way, if somebody else is looking at your program, they can figure out what's going on. But I've explained each feature in detail, so I'm not gonna bother. So we've got these lines. That's good. Let's go ahead and get some characteristics. So I'll start with the flatness because it just happens to be the easiest. Go to the computer screen. I wanna go to the form and location tab. If you notice, there's a ton of options. Most of these are GD&T characteristics. Now, I need to mention that Calypso is done in the ISO standards, not necessarily ASME. So there are some things you gotta look for. For instance, concentricity is not default to the ASME version of concentricity. It's interesting enough, ISO their concentricity makes way more sense than ASME, but they mean different things. So if you're ever checking something, you want to make sure the settings in the computer are correct. For our purposes right now, it really doesn't matter that much. So I'm going to go to Flatness. Now it brings us to the Characteristics tab. If you notice, there's a little gray box next to Flatness. That means it hasn't been checked, it's not programmed, just totally blank slate. I want to go to the pen tool right here, open selected object. It brings us to the Flatness dialog box. The first thing I want to do, because it's easy to forget, is punch in the tolerance. So it's 2 thousandths, so decimal place, 2 zeros, 2, okay? Now, I want to choose the feature. There's 2 ways to do this. Now, if I have my cursor in here, I can come out here and just click on the feature. You want to click on the line, okay? So the plane has 4 lines. You want to click on that line. It won't work if you just click on the word plane 1. Now, the other way to do it, I can delete this. I can click in this gray box and select plane from a list. Both ways are legitimate. You can do it any way you want. Sometimes clicking in the CAD window can be difficult. If there's a bunch of lines and stuff stacked on top of each other, it can be tricky to see which is which. If you pick them from the list, especially if you named all your features, that can be a little bit easier, but it's up to you how you want to do it. I'm going to hit OK. And now we're good to go. Because that plane was part of our alignment, the computer's already measured it. It already knows what's going on with that. So if you notice in this dark gray box, it gives us the actual measurement, right? So it happens to be like 0.3 of a thousandths. It's good flatness wise, right? So I'm gonna hit OK. And if you notice that little green box next to flatness, the little box is green. That means that characteristic has been checked. Now, this only has been checked because it's part of the alignment. We're going to want to measure that 3 inches plus or minus 20 thousandths. What we'll do is go to size, distance, and in this case, we'll use a caliper distance. Okay, so caliper distance, again, we got this gray box. I'll hit the pen tool, and we're going to select the lines we want to measure between. So in this case, to measure from left to right across the part, we're going to choose 2D line 1 and 2D line 3. So I'm going to click in this gray box, 2D line 1, hit OK. This gray box, 2D line 3. And you can see they're highlighted in the CAD window. Hit OK. And it's going to give us a number down here, that actual. So we're going to want to report this X, right? So I'm going to hit this X checkbox, and then I'll punch in my tolerance. So it's 20 thousandths on one side, 20 thousandths on the other. One thing you want to watch out for, the lower tolerance needs that minus symbol in it, okay? Or else the computer will get all confused. So remember, the upper tolerance is plus, the lower tolerance is minus. So remember that minus symbol. You know, if you select all and delete it and just punch in 0.02, it won't do quite what you want it to. Okay, so hit OK on that. And you can see visually on the screen how it's going to measure that feature, okay? So that's why I chose caliper distance. You can see exactly what the computer is doing. Now we'll measure the other caliper distance. I go again, size, distance, caliper distance. Now we want to go between 2D line 2 and 2D line 4, okay? Same idea now. So we don't have to punch in that 20,000 tolerance twice. We can go to this drop down and choose last input, and it's going to put that in there for us automatically. So this is really handy for repetitive type stuff. And actually I selected the wrong, it's going to be the Y direction that we want to measure, okay? So these caliper distances are based on the coordinate system of your part. So I hit OK. So now we've got those two distances from the drawing. That's good, right? We can see from the actuals that they're already good to go. Because when we probed the part, the computer figured out approximately where they are. But remember, we only took 2 points when we probed it. When the computer goes to scan it, right, it might come up with something different. So that's subject to change when we run the entire program. So even though it says it's good to go now, it could change. There could be a bump or a groove in here that could screw it all up. So we're still got to run the program to actually check the part. Now, we want to check the holes, right? I'm going to show you 2 ways today to get a circle. The first, we're going to go in and we're going to probe, right? You want to do 4 points for a circle. If you do 3 points, it's just going to give you an arc, and it'll only scan between those 3 points. If you do 4 points, it'll do a full 360-degree scan, which is good. Okay. So I'm going to release the machine. I'm going to drive down into the hole, again about halfway down. I'm going to drive to the top first. It'll take a point. I'll go straight back to the bottom, take a point. We'll move it back to the middle, go to the right, take a point, then go to the left, take a point, go back to the middle, drive the machine up. And you can see on the computer screen, it misinterpreted my circle as a sphere. No big deal, it's easy to change. We're gonna go to this drop down and select circle, okay? And the computer will automatically refigure, okay? So when you take points, it's gonna try to figure out what you're looking at. Occasionally it's wrong, right? So what we wanna do here, let me hit OK. I'm gonna go to the characteristics tab. If you notice, there's no diameter or X and Y for the circle. It's not outputting anything to the report. I want to go to features. I'll go back into this circle, hit the pen tool. I want to hit this X checkbox, this Y checkbox, and the D checkbox. So D stands for diameter, X is the distance in X, Y is the distance in Y from the origin that we established in our alignment, which should match the origin of the drawing, okay? So it's this bottom corner of the part. Now, we've got to go in and add our tolerances. If you remember from the drawing, it's the locations are plus or minus 5 thousandths. So I'll punch those in now. And then the diameter is plus 10 thousandths minus 4 thousandths, okay? So it's easy enough to punch all of that in. And now we'll just hit OK. And if we go to the characteristics tab, we'll see X value, Y value, and diameter, okay? So those are gonna get output to the report when the actual program runs, right? Cool enough, right? So what we could do with these, because when you check this part, you're gonna have 16 of these 3, it makes a long list, we can go ahead and group them. So I'm gonna select all of them with the Shift key, right click, form group, and then we could rename this group. And just name it hole 1, okay? And then to open it back up, we just hit this arrow. Now, unfortunately, there's no way to really speed through this process. You got to probe every single hole, okay? So you could go in and take the 4 points. Another way to do it is with something called a 4-point macro, which is great for situations like this where you have a bunch of repetitive holes to check. So the way the 4-point macro works is I'm going to drive into that second hole. I'm going to hit F11. You can do it on the computer keyboard, or you can do it on this keyboard, right? So hit F11. You can see it on the computer screen. It's the selected probe in the center of circle. If yes, which it is in this situation, and hit OK. So you could hit the Enter key on the computer keyboard, or you can hit the Return key on this keyboard. So I hit the Return key. The probe is automatically going to take 4 points for you, right? When it's done, it's going to bring you into the strategy right here. So we're just going to leave that as a 4 points instead of making it go in a scanning path. In another video, we'll talk about how to go change the strategies. I'm not super worried about it right now. So just go ahead, hit OK. And then again, we're going to report X, Y, diameter. So it's going to remember your last input. Unfortunately, the last input was for the whole diameter. So we got to go in and change the tolerances for the X and Y. No big deal. And I'm going to hit OK, right? So go ahead and group these holes together, rename it, hole 2, okay? So you just repeat that 16 times, or 14 more times in this case, to get all 16 holes measured up. Just follow those steps, you'll be fine. You can scan the or you can probe the 4 points, or use the 4-point macro. Remember, when the 4-point macro is done, to take the probe out of the hole. I mean, you still have to drive it to the center of a hole, but it can be kind of a time saver. So now, we got everything on the drawing. I'm not going to go through all 14 holes, but I will show you how the program is going to run. So when we want to run a program, I'll go down here to Run Measurement Plan. I want to use the alignment mill part 1, so it's going to run the alignment again, okay? Which typically you want, because it's already checking features that are in the characteristics list. It's just a safe alternative. Maybe somebody came in last night and tilted this by a 1/4 inch. If you run with current alignment, the computer might smash into something. So it's good to run the alignment from the program you've got loaded up, right? So I want this box checked, the clear existing results, right? And I'm gonna hit start. All of the other settings will leave as default. And then the computer is gonna do its thing. It'll do all the features we had in the alignment, and it's gonna go ahead and check those new features. I wanna keep an eye on it just to make sure, again, it doesn't smash into anything. Sometimes it can do wacky stuff. In the future, we'll get more into the clearance planes and being able to check and make sure you're not gonna smash into something. But for now, just keep your hand on the speed wheel anytime it's changing features, okay? Okay, so that's it. I guess I made a mistake. I thought the first hole was going to do a scanning pattern, but it just took points. No big deal. Later, I'll show you how to change the strategies. Typically, you want to look at the strategy for every feature. We didn't really do that today, but the machine didn't crash, so that's great. You can see on the computer screen the report. So this is called PyWeb. This is one of the ways Zeiss or Calypso will give you a report. We can go ahead and zoom in here. It gives you the measured value, the nominal, the tolerance, and a nice little graph about whether you're in spec or not. So it's part passed, that's really good. This can be saved as a PDF really easily. This is the output of this whole process. People don't care about what the machine does or how the program was written. They just want to see this document and see if the features are in spec or if they're not in spec. Okay, this is another reason to name features, or at least name them something, compare them to the drawing. So if you circle it on the drawing as feature 1, call it feature 1 here, so you can compare them side by side. Okay, so you could save this as a PDF and turn it into your instructor, or if you're really running parts out in industry, this is how you would do it. Okay, so that's it for this video. Some basic features. If you enjoyed the video, please like and subscribe, and check out the channel for more of this content coming soon.